In this question, we are given a rectangular box with the dimensions length, width, and height as L, W, and H. And we are also told that the length and width decrease at a rate of zero point 0.2 centimeter per minute. So mathematically, I have written these two information as dl over dt. This represents the rate of change of length. I put a negative because it is decreasing. So I write down dl over dt equals negative zero point 0.2 centimeter per minute. And similarly, the width also decreases by the same quantity. So I write down this as dw over dt. This equals negative zero point 0.2 centimeter per minute. And also the height is increasing at the rate of zero point 0.1 centimeter per minute. So I write down this as dh over dt equals zero point 0.1 centimeter per minute. Notice that it's increasing, so I did not put negative here. It's just a positive quantity. And using this information, as well as when the length equals 11 centimeter, width equals 3 centimeter, height equals 2 centimeter, we have to determine the rate of change of volume. So let's see how to determine the rate of change of volume using this given information. So first, I write the equation for the volume of the box. Let V represents the volume of the box. Then the formula is length times width times height. And since we wanted to find the rate of change of volume, we differentiate both sides with respect to time. So derivative of V with respect to time, we write down this as dV by dt. And this quantity indicates the rate of change of volume. Rate of change of volume. So let's see how to find the derivative of the right side expression. Here we have a product of three quantities. Every quantity is a variable and each one has as the rate information. So we have to consider any two products or any two quantities as just a first. So I'm going to consider this as first, and I'm going to consider the last quantity, that is height, as second. So we are going to apply the product rule here. So the product rule, according to the product rule, we find the derivative of the first. That is, we can put this as d by dt of length times width. So I put LW times the derivative of the, I'm sorry, we have to put the second as it is. So the second is H plus, put the first as it is. The first is length times width multiply with the derivative of the second. That is, we write down this as d by dt of the second is h. Now let's continue. Notice that we still have to find the derivative of this quantity as well as this quantity. So once again, we can apply the product rule here. That is, to find the derivative of LW, we have to apply the product rule. So I'm going to consider this length as first and then the width as second. So we will apply the product rule here. So first we have to find the derivative of L. So derivative of L with respect to time, this equals, we can write down this as dl over dt. This is derivative of L. So I put dl over dt times the second. The second is width here, plus we now put the first as it is. That is, the first is length times the derivative of the second. The second is w. So the derivative of w with respect to time, we write down this as dw over dt. Notice that this is the derivative of lw, and this whole quantity has to be multiplied with the quantity h. So we can put a square bracket and put it as h. Now let's find the, or we simplify the second. In the second, we have L times of W, that is length times width, and then d by dt of h. This is nothing but the derivative of h with respect to time. So we can write down this as dh over dt. Now we have found the derivative of the volume, that is dv over dt. This is the rate of change of volume. We can put the available information. So I'm going to substitute the information which we have already written here. So dl over dt is negative zero point 0.2. I'm going to replace dl over dt as negative zero point 0.2. In fact, for dw by dt, because it is also negative zero point 0.2. So then I have the square bracket here. Now I replace w. W is 3 centimeter. So I just put 3 here, plus the length is 11 centimeter. So I put 11 here times dw by dt, that is the rate of change of width. We know that it is negative zero point 0.2 times the height. The height is 2 centimeters. So I just put 2 here, plus substitute for these quantities, that is length times width. Length is 11 and width is 3, so it is 11 times 3 times dh over dt, that is the rate of change of height, which is zero point 0.1 centimeter per minute. So I can put zero point 0.1 here. Now let's evaluate this. So this equals negative zero point 0.2 times 3 is negative zero point 0.6, and this also is a negative product. So we will get 11 times of negative zero point 0.2 is negative 2.2, and this has to be multiplied with the 2. We have a positive quantity, plus 11 times 3 is 33, and 33 times zero point 0.1 is 3.3. So I put 3.3 here. So let's evaluate this. This is negative zero point 0.6, negative 2.2, which is negative 2.8 times 2 plus 3.3. This is 3.3. And so negative 0.28 times 2 is negative 5.6 plus 3.3, and this gives negative 2.3. We put this unit, since this represents dV by dt, that is the rate of change of volume, and this equals negative 2.3. We put the unit as centimeter cube per minute, because the unit of volume is centimeter cube as given in this question. The unit is all in centimeter, so we put the unit of volume as centimeter cube, and for the time it is minutes. So we have found the rate of change of volume as negative 2.3 centimeter cube per minute. Otherwise, we can also say that the volume is decreasing at the rate of 2.3 centimeter cube per minute. So alternatively, we can say that volume decreases at rate of 2.3 centimeter cube per minute. But the rate of change of volume represents this quantity, that is negative 2.3 centimeter cube per minute.